Hi, my name is Tim Cho, and I'm an application engineer here at Transom. And welcome to the ALTERA FPGA Power Design demonstration. The purpose of this tool is to provide the first few steps in designing the power solution for a given FPGA. Before we begin, we recommend running this tool in the latest version of Firefox. So let me show you how to get to the tool from ALTERA's website. From ALTERA.com, click on Electrical Components, then select Online Design Solutions, and that brings you to Transom's designed web. The power button here, go ahead and select that. Click on Applications, and then Embedded. And here's the ALTERA FPGA Power Designer. Select the play icon. That takes you to the registration page for the ALTERA Power Designer. So if you're a new user, you can register for a new account here by clicking on Register Now. Since I already have an account, I'll sign in with my info. Enter a password. And start a new design. So this is the main workspace of the FPGA Power Designer. This is the schematic canvas area. This is the schematic toolbar, which has print features, zoom features, and a marquee tool. This is the clear all button, just in case you make a major mistake and you want to start from scratch. The check design validates your design. So to begin, we click Add Component and select FPGA. Click OK. And now we can place an FPGA symbol anywhere on the schematic canvas. Double-click the FPGA symbol to define it. And the FPGA configuration dialog box opens up. And the first thing to do is to actually select your FPGA. So from this drop-down menu, we can see a list of available FPGAs. Right now, they're just ALTERA FPGAs. Select the Stratix 4E. And if there's a configuration for that FPGA, it'll be listed in this drop-down menu. So down here, this lists the power pins for that FPGA, as well as the voltages and the supply tolerances. As a user, you can specify the current, which is something you may already know, or it's something you can get from ALTERA's early power estimator. And you can just enter those values here. We'll just use some random values. Also, there is a checkbox here, which is labeled Use Default Power Tree Configuration. So this just enables you to use a default power tree, which is based on ALTERA's pin connection guidelines. It's just a template, really, and we recommend you leave this checked unless you're an advanced user. Click OK. So as you can see, there's a structure of converters and filters, and it appears because we had chosen to use the default power tree. If you unselected it, then you would just be left with the FPGA symbol. One thing to note about this tool is that it's meant to work from right to left. So we've just defined the FPGA. Now we need to define our converters. So to do that, just select a converter and double-click on it to define. And you're presented with a dialog box. So the purpose of this dialog box is to help you select a converter, and you can enter your requirements and features here. The main requirements are input voltage, which is here, and your output voltage, and your output current. Notice there are detected values in green. The tool senses what voltage and currents are connected to the converter, and it'll display them here. Also, there's a column called Recommended, which is down here. This column shows which converters were recommended by LT for specific voltage rails from this specific ALTERA FPGA. For this demo, we'll just go ahead and select the LTM 4627 and select this part. Okay, and we'll go ahead and repeat the process and just select another part here. We'll select the 4601, select. Alright, so let's say you know your input supply will be 12 volts. You can define that here with the DC input symbol. Double click on it to define it, and you can select 12 volts. If you have a custom value, you can enter that here. Select OK. Notice we received our first design check error. Clicking on it will take us to the source of the problem, and it says voltage error. The voltages of the node containing PS1, S1, S2 are not equal. So that text that's in bold is the reference design number rather, the ref des. So PS1 is the DC input, and S1 and S2 are the converters, and there's a voltage error. So if we look closely, we notice that 12 volts here is on the same rail as 5 volts for the converters, and obviously that's not correct. So to fix the issue, we can redefine our converters. Double click on the LTM 4627, click on reselect, and we notice that the tool detects 12 volts. So if we enter 12 volts in, we have basically fixed the issue for that converter, and we can address the issue for the other converter. Alright, and then we'll enter 12 volts there as well. So notice the design checks ran, and we no longer see an issue. So let's say we want to take this design one step further. We can select a converter and design it. So if we double click on the LTM 4627, we get this dialog box that pops up, and we can select design it. And it's basically taking like a deeper view of this specific converter. It kind of dives down into what's inside the symbol. Click design it, and you're brought up with what we call the designer. So here the designer pulls in V in, V out, and I out from the schematic, which has already been defined. And we can click on the Create Design button, which calculates the peripheral component values like resistors and capacitors based on design equations from the converter's datasheet. And those values are displayed here in the schematic. Pressing Continue will introduce you to the bill of materials. And the tool basically took those values and assigned an actual part to them. So if there's a part here that you don't like, you can actually change it here by pressing the magnifying glass icon. So let's say that this capacitor C2, you don't like it. It's an AVX part, and you want a different part from a different manufacturer. So you can select, for example, a ChemNet part, and any other filters that you wish to use, and then you click Apply Filters, and the filters that you apply show up here in this column, and you can select a different part down here. Alright. So once you're satisfied with your bill of materials, you can press continue, which takes you to the summary. And the summary is just an overview of what you've done for this converter, and it provides you with a schematic and also a bill of materials you can download. Clicking the Finish button will save what you've done and return you back to the schematic canvas. So we've just defined the LTM4627 in a little more detail. You can go ahead and define the rest of your converters and select the rest of your converters. But now let's say you want to add a custom load to one of your rails. You can do this by selecting Component, Load, and you can drag your load anywhere on the schematic canvas. So let's define this load by double-clicking it and entering your load's voltage and required current. And maybe we'll just call this custom load. Click OK. And now we've defined the load. Now we'll connect it to, let's say, S2. So their hash marks show that you can select the wire, and if you just click and hold and drag it to another rail, the hash marks then get bigger, which says that a connection can be made. You let go, and alright. So now that it's connected, we can check our design by clicking Check Design. And we see that there's another error. So we can click on the error to see what's wrong. And it says power error S2 power out is not greater than or equal to U1.group3, U1.group4, U1.group5, and our custom load GL1 power in. So basically the power requirements from the FPGA and the load are higher than what the converter is providing. So we can double click on the converter to fix the issue, reselect, and we notice that our load of 3 extra amps is creating an error. So it's detecting 9 amps, so we can change our requirements to 9, and we can reselect the part and click Select Part. And now we notice that the error is now fixed. So now when you're satisfied with your design, we can progress to the bill of materials. And obviously we haven't completed the design. There's parts which we haven't selected, and we haven't used the designer in some of the converters. But for this demo, we'll just continue because just to save time. Alright, so this is the top level bill of materials, which will show all the components from all the converters that you have defined. And it's a high level BOM, so it's a little different than the bill of materials which we saw earlier. You can download this BOM by selecting this Excel download link. And once you're satisfied with your bill of materials, you can press the summary to advance to the summary page. Here, the summary page provides you with an overview of your schematics and also your design checks and whether they passed or not. And it also has some links here which will take you to the early power estimator. There's some links here that take you to the pin connection guidelines, and you can also click to enlarge the schematic, and it'll basically open the schematic in a larger view. One other feature worth mentioning is the save and sharing of a design. So there's what we call the design manager up at the top left, and here you can save your work at any point in time. So it doesn't have to be at the summary page. You could save it in the middle of a design. Just click the save button and then give your design a name. Click save. And you've successfully saved your design. If you wish to share your design, you can just click share. Maybe you have another colleague or a customer which you want to give them access to it. You just enter their email address here, and I'll just use Max's email. And then here you can specify whether you want to just give, for this, in this case, Max read permissions or read-write access. And then you can click send invite. So this will send an invitation to Max's email for him to open up your design and continue working on it, or providing feedback. If you wish to open a previous design, you can click on open, and you can scroll down and pick an older design. Say OK. And this brings up, a design that you may have finished, or an older design that you're still working on. This concludes the tutorial of the FPGA Power Designer. If you have any comments or feedback, there's a button in the top right-hand corner here. This is just the first version of the FPGA tool, and we plan to improve the tool in future versions. I hope this was helpful. Thanks for spending the time to learn about it.